So today we're going to be talking about Hoffman elimination. So first let's review some 118b. So if you remember from 118b, if you have a really bulky base like LDA or tert-butoxide, you form the less substituted alkene. So you have a bulky base and a small leaving group, which leads to the least stable alkene. But however, in 118b, the roles are reversed. Here, you have a bulky leaving group followed by a very small base. So here that's small, and this is bulky. So because of that, you can assume it will give you the least stable alkene as well. Stable C++C. So here, you can see the concepts are reversed. So now let's get into depth with the reaction. So let's say I have a substrate, or no, let's first cover number 1, exhaustive methylation. So let's say we have a basic or just NH3, and here we know that from 118A, NH3 is a good nucleophile, so it's readily going to react in an SN2-like fashion. There it is, and it kicks the I out. Now, this is sort of acidic. So what's going to happen is another NH3 in solution is going to come in and deprotonate. So here we have NH4 plus, and then NHH. So remember that methyl groups push by induction, right? So because of that, this one is more basic / nucleophilic than the starting material. So if it's more reactive than the starting material, it's going to keep on going until it can't react anymore. We're going to exhaust the lone pairs until there's nothing left. And that's why eventually you form a quaternary ammonium. Quaternary charged ammonium. And that's the basis for Hoffman. So, knowing that, let's look at this question. N H. Alright, so as we know, the first step is exhaustive methylation. In excess or in one equivalent, depending on how substituted your nitrogen is. And when we're eliminating, now we look at 2 carbons away from the leaving group. 1, 2. Here there's an H. 1, 2. And here there's an H. And then in solution, Ag2O, H2O, and heat makes hydroxide. Now, which hydrogen is less hindered? That is the one that the base is going to get. So if we look at this one is surrounded by 2 methyl groups, versus here, this one is surrounded by 1 methyl group. So that one is least hindered, and the base will go in for that H. Goes in, and then the leaving group gets kicked out. Plus, from that new bond. And that's Hoffman. So what happens if we have a cyclic example now? So here, for the cyclic example, so step 1 is exhaustive methylation. Here we're only going to use one equivalent because one equivalent is going to take to get it to that ammonium salt. Again, we have our OH. And here we always look 2 carbons away again. So that's 1 carbon, 2 carbons. 1 carbon, 2 carbons. So, which hydrogen is left hindered? The left or the right? Pause the video and determine your response. Or you can just do the particular product, I don't really care. So if you said the right one, that's correct. Here, there's a CH3 group that's making it pretty hindered. So again, the one on the right is less hindered. So here, the base is going to attack the H, come in, break the ring, because the leaving group is a part of the ring, and we're making it leave. So here we have N, with its new lone pairs it just got. And then the broken ring. And that's all for Hoffman. I will have practice problems listed on my website, so feel free to check that out. Otherwise, thanks for watching.